Hi, can you hear me? Hello? Okay, great, awesome.
Recording in progress.
All right. Oh. Hi, can you hear me? Hello? Hello, can you hear me? Why is the volume? Why? How do I turn off on mute? I am muted here. How am I hearing if the volume is low? Hello, hello? Hello? You still hear me? Off here. Feedback. Fine. Output. Hello? All right. Do you still have feedback? Okay, no feedback. Okay, good. All right. All right, welcome back. Oh, the lights. There we go. Is that better? Yeah. All right, so let's take a look at the calendar, see where we are. So I believe we're finishing up the second week. Yeah, so already we should have a working database server. We should have a working database client, right? We are using MySQL as the server. As a client, I think we're all using Workbench, although if you prefer to, if you're more familiar with some other clients, you're welcome to use that as well, especially if you're on a Mac. There's quite a few other ones that you want to use. Also on PC, there's Toad, there's a whole bunch of other clients that you might want to use. Nevertheless, all the examples that we're giving you are based on assuming that you're using Workbench. Yeah, so we have presumably we have the setup all done. We started talking about designing a database. We saw that it all starts with a meeting with our clients, trying to design, understand what it is that we're building, what we're not building, and that anything we code, anything that we build is based on those requirements, right? On a mutual agreement. Also, how we deal with those requirements has evolved over time. We used to use the waterfall methodology where we gather the requirements, we go out for a year or so, and then we come back and give them exactly what they asked us to do. And when they start using it, they hate it, right? And it's awful. It's terrible. More lately, we've been using more like an agile and iterative approach, right? Where we involve the client in the loop of decisions, right? And every time we build something iteratively and incrementally, we demo it, and then we get some feedback, and that feedback loop goes into the design, right? So you find yourself modifying your code quite a bit, right? Even the design of the database, you might find that your requirements change, and you have to go back and change a few things. Okay, it's normal. So the best way to do design, we said that it's to best do it in a graphical environment, such as tools such as UML or ERD diagrams, where the data that we're designing is represented as boxes and lines. Okay, it's easier to make changes and move things around and understand visually what it is that we're building, right? And then there's all sorts of automated algorithms that will convert the graphical representation into anything you want, right? You can convert it into SQL as a whole bunch of create statements. You can convert it into Java, C#, anything you want, right? And vice versa. You can go do inverse round robin reverse engineering, where you can take a look at the source code and it can reverse engineer what the data structures are, right? And create the SQL or the non-SQL tables and for the database that you might want to use. So really cool tools. So really it all starts with a graphical representation of what it is that we're building, right? UML. And so we started on that. We explained what class diagrams are, gathering requirements. I think we covered a simple algorithm that can take tables, right, and convert them into classes. Today we'll go the other way around. We'll start with classes and convert them into tables. The algorithm is not perfect. It deals with maybe 80% of the things that you normally work with day to day. But there's certainly tons of edge cases, right? On how, what do we do here? How do I convert this class, this inheritance, this enumeration? How do I convert that into a relational database, right? Or vice versa. How do I convert this weird thing in relational database as a data model? So we'll talk about that. Perhaps we'll start talking about relational algebra. And we'll talk about the new assignment, right? The DB1 is due this weekend, I believe, and so. But let's get started talking about DB2, and which is basically exercising what we've been talking about, the design process. Okay. Any questions before we get started? Yeah, so no quizzes this week, but the end of next week, we do have our first quiz, right? And it'll be mostly just about design, right? On UML and how to design and things like that, right? So it'll be the focus. So at the end of next week, and it is in class. You need your laptop. All the questions are on Canvas, and they all fill in the blanks, multiple choice, and you get graded immediately. Okay, you get a grade right away. All right. That's next week. Remember, bring a laptop. Yes. Sure. Yes. It's really quick. If you don't know where things are, you'll take longer looking for things, and then I found open books to be a hindrance, actually. It's like then professors tend to go a little bit harder on the quizzes because they know that you have access to all this material, so they'll do some really weird questions as well. You have your notes. Let's see, something on the chat. What's going on? Much better. Okay, great. All right, yeah, let's take a look at the upcoming assignment, designing. What is the format? The format of the quiz is multiple choice, fill in the blanks, right? And it shouldn't take you more than 20 minutes to complete the quiz at the beginning of the class, right? And if you do find something, a weird question, misspelling, maybe take a screenshot of the question and then send it over maybe on Piazza, and then what I'll typically do is I'll create a post where everybody can reply. and say, oh, this is what I answer. I think it's correct, or I think there's a typo, and so we can just fix it for everybody. Okay, all right. Okay, so this assignment is going to give us a chance to practice the design phase of a database, right? It's going to give us some explanation on certain data types that we want to implement, some attributes, some data types, right? And we're going to convert that into a class diagram, right? Like most of the assignments, there will be a part where we walk you through the whole process, right? Where we do it, right? We give you the answer, what it is, right? You just have to recreate it exactly what we give you, yes, right? And then we ask you to do it yourself. Well, we'll explain it in plain English, right? And then you have to understand, process that, and then implement what it is that we're explaining on your own, right? So we walk you through an example, then we ask you to do it on your own, right? Example on your own, example on your own, right? So here in class, I'll demonstrate the part where we walk you through the whole thing, right? And you're welcome to use whatever I have. I'll share it, and the idea is that you get a chance to play around with it on your own. Okay? So let's see. So first of all, we'll need to install a tool that will allow us to create these UML diagrams, right? So yeah, the learning objectives is to learn how to use the UML class diagrams to represent data and its relationships, right? We'll implement some of the more common types of relationships, right? The more common ones are the one-to-many and many-to-many. We also have one-to-ones. There's also self-referencing, right? There's inheritance, there's enumeration, okay? Some of those are, we're gonna let the graduates play around with those. Some of the more advanced ones, we'll play around a little bit later on, but we'll cover here the more common ones. Good question? No, I would do that later. Yeah, I'd rather you just pay attention, right? And you have the video recorded if you want to take a look at it again, and then you can follow along if you want. But here, I think I prefer you be passive, a spectator. Yeah, right. So there's quite a few tools out there, right? There's tons of them. Some of them are free. Some of them you have to pay for. I believe if with the university account, you can use Lucidchart and just log in, and you already have an account. Maybe, I'm not quite sure. There is a free version of Lucidchart, which allows you to draw maybe 100 diagrams, something like that. That's plenty for this class. So you should be able to just use the free version of Lucidchart. There's also tons of them out there, Creately, Flowchart Maker, this ideal modeling diagram. There's tons of them out there. I use Lucidchart. That's the one I'm going to be using for this lecture. Okay. If you type Lucidchart here, I believe I'm logged in already. Okay. Documents, cs3200, fall. All right, let's create one for the assignment DB2. All right, so I'm just going to say new Lucidchart blank document, and we'll call it DB2 fall 21. Okay, there's tons of shapes that you can use. We're going to be mostly using UML shapes, so I'm going to close these. Right, I'm just going to leave them there. But you can certainly install more types of shapes. We're interested in the UML shapes. So I'm just going to click on this and I'll say, yes, those are what I want. They have UML class diagrams, UML use cases that we talked about last time we met, right? On Tuesday, we talked about use case diagrams. You have sequence diagrams, also very, very important. Deployment, relationships. Okay, so here you have class diagrams you can drag, and you have, boom, a class diagram you can play around with. Okay. So this assignment asks you to do a couple of things. So one of them is we're gonna be building throughout the semester a database that could be used for some kind of social networking application, right? So most of us understand social networks and either microblogging or full just blogs, and so we should be familiar with that domain, right? We sort of understand that domain. And so I'm going to be using several nouns that should be familiar to you, right? Because we understand that domain. Everybody's been using social networks for quite a while. And so there might be a lot of assumptions that we might have about particular nouns, right? And certain attributes that those nouns have, and the data types that those attributes have, right? It's a little more challenging when we're talking about a domain that we're not familiar with, right? So somebody asks you, well, create me a data model for space exploration or chemical compounds or nuclear fission, whatever. I don't know. There might be some domain that we're not familiar with, right? And they might be using a whole bunch of terminology and a whole bunch of nouns and verbs that we just are not familiar with the vocabulary. Yes, all right. Now, the more you know about a particular domain, you might make certain assumptions of how things are related to one another, right? That one of these is related to lots of those, right? Or many of these are, for every atom, there's a whole bunch of electrons, right? And so you might know these relationships because you're familiar with the domain, right? The less you are familiar with the domain, the less you're familiar with how to model it, okay? Now, also be careful that if you're too familiar with a domain, you might bring a lot of baggage with you, right? This is, well, this is how I've modeled it in the past, and you have this tunnel vision that you can't think out of that box, right? So you have to be careful, knowing too little or knowing too much, okay, and not being open to new ideas, okay? So the first thing that we're gonna ask you to model is a class that defines a blog, right? And a blog is if I'm the author of a blog, it could be thought of some kind of a magazine that where I can post a lot of articles that I create over time, right? Where I talk about all sorts of topics. Yes, and I might have one blog that talks about my favorite sport, and I have another blog that talks about going on vacation to exotic places, right? So each blog typically is associated or dedicated to a particular topic. Yes, right? So perhaps you could think of it as like a magazine, as a collection of articles, right? But instead of calling them articles, we might call them posts, right? You create a blog and then you create a whole bunch of posts within that blog, right? And those are like micro articles that talk about different experiences. Make sense, right? So the first thing that we're asking you to do is okay, well, what would you capture? What describes a blog? So here we're going with something really, really simple. The name of the blog, the topic of that blog, when it was created, and the last time that it was updated. Okay, so yeah, we're going with something really, really simple, right? So blog, 4 attributes, 2 strings, and 2 dates. Okay, so if we go to our Lucid chart, we might do something like this, where we how do I? When I say blog, and these are the attributes that I'm going to be using. Usually we, especially if we're implementing this in a object-oriented language, typically attributes are defined as being private, right? That's a good practice. Attributes or properties are defined as private. That's why we go with the minus sign, and we go with the name of the blog, and then this is a string. Depending on the language or your preferences, you might go with lowercase string or uppercase string. I don't really care which one you go, as long as you're consistent. If you're going with capital S, then stick to capital S. Name, then we have the topic, string, and then we have created with date and updated. Okay, we said that for this class, we're not going to care about operations. Obviously, if you're going to implement this in a particular programming language, you'll probably have a whole bunch of mutators that go along with this, right? Set, get, one of all those setters and getters that go along with that. Yes, probably a constructor has a whole bunch of copy constructors, a whole bunch of things that we don't care about that, right? When you're programming, yes, that definitely matters. So there's our blog, our very first class. And then this asks, okay, well, now you try it. Create a post class diagram that has the following attributes. Very, very similar, right? It's going to look almost identical to our blog. right? But instead of a name, it's going to have the title of your blog, of your post, right? And as you create it, right? The next thing might be, how are these related to one another, right? Well, each blog might have a whole bunch of posts. Yes. Transfer tools like converting them into SQL. Yeah. Well, for designing, definitely it's always a good idea to start with these graphical tools. Those tools that you're talking about are not are usually very expensive, and most companies won't have them. And they'll be mostly mostly they'll use the UML only for talking about the problem, designing it, knowing that immediately they're going to jump into actually implementing this in SQL, and only use it as a documentation tool or as a discussion between engineers on how to talk about the problem, but not an actual implementation. Also, these tools, oftentimes you have to go in and tweak it anyway, because you might have a particular idiosyncrasy of naming conventions or that are specific to your project or to your company. So anyway, you will be tweaking whatever output of these tools are. But definitely, yes, these tools, Rational by IBM has this really amazing tool that can do all these kinds of backwards and forwards engineering. They're really great. But yes, now eventually you're going to be doing this by hand at some point. Yeah. Well, up until AI substitutes us all. And anybody seen some of the examples? GPT-3. I think that's kind of scary. That you can just, in plain English, as you type, explaining the problem, right? It's coding for you, the UI, and coding for you. You following good programming practices, and it's amazing. Scary. And it learned by looking at all the GitHub repositories, how folks are coding, and it learned using neural networks, and now it, as you type it, scary. Anyway, so yeah, so it asks you to create a class, right, called a post, right? And so for now, I'm just going to create here post, and you create the attributes and the operations. So that part you'll do. Then it asks you, okay, well, let's implement now some relationships between the different classes that we're going to be using, right? So for instance, here we're talking about implementing relationships, one-to-many relationships, right? Using the class that we just created, blog, plus another class, right? Relationship between two different classes. And the one that we're being asked to do is between the user and the blog, having one user maybe having multiple blogs. One blog where I talk about cars, and another one where I talk about space, right? And so it's like two different magazines, two different sets of articles that I'm gonna be covering. Yes, right? So what I want to be able to represent is that one user can have multiple blogs, right? One on education, another one on technology, another one on whatever, right? And the way we say that we're going to represent that is with this line between them, 1, 2, star, right? On one side, the one on the strong side, and the star on the weak side. Okay. All right. So we'll need the user class. Let's do that. This will be the user class, and then the attributes here. Why is this centered? So we have, what do we have here? First name, last name, create another. Okay, so this is first name, last name, create it, date, and update it. Okay, no operations. Okay, also notice the naming convention, right? The naming convention is following camel casing. as opposed to the way it's going to be converted in SQL. In SQL, you would use instead all lowercase and the underscores between the words. Yes, right? So these tools, like you were saying, right? These tools would know about these idiosyncrasies that, in UML, typically you use camel casing, but in SQL you use underscores, right? And these tools would be smart enough to go back and forth and understand that this would be converted to, first underscore name, varchar, and this would be last underscore name, varchar. Yes, right, and vice versa. If it's parsing with underscores, it would convert it into camel casing. Okay. Also notice that I'm following a pattern here that I'm always going to add these two fields, created and updated, to all my classes. Okay, and presumably they would be useful in a relational database or a database in general, just to keep an audit, right, about a particular record. When was this record created, right? So that we could track, when was it created, maybe who created it, might be interested, right? Also about when was it last updated, another interesting thing. Well, who was the one who last updated that record, perhaps, right? So these are very common fields to keep track of in any database, just for auditing purposes. Okay. Yes. Yeah, I'm not following my own naming convention. Let's do it all lowercase because it's one keystroke less to type. But yeah, no. Please be consistent. Be consistent on whatever casing are you going to be using. Definitely the attribute names are going to be camel cased. Here in SQL, it's going to be underscores. All right. Yeah. So right, we're going to be creating the relationship between these two, like that, and we'll say that we're going to have the none on this left-hand side, and on the left-hand side, we might decide, we don't have to, we could decide to document also if there's any type of life cycle dependency, right? For instance, we might establish that that this is a composition, right? Or an aggregation, right? With the open diamond, we said that that's an aggregation, meaning that if the record of the user is removed, right, nothing happens to the records of the blogs. The blogs outlive me, right? If I am removed as a record, right, the blogs stay. Right? That's probably a good business decision from the owners of the software, right? They want to keep the content going even if you leave, right? They are the owner. Usually that's part of the agreement when you sign on to use the website. Any videos or pictures that you upload or any content that you write, they're the owners, right? They can do whatever they want with that content, right? And that's typically probably how they implemented it. It's an aggregation. You can leave. We own the content, nevertheless. Okay. Now putting the diamond here usually is implied. The diamond, putting the diamond here it's already implied that this is on the one side of a one-to-many relationship, right? So it's kind of redundant putting the one and the star, right? Because somebody who knows how to read this already means that there's a one on this side and there's a star on the other. Nevertheless, right, we're going to go that extra inch, right, and we're going to add the multiplicity, right? Add multiplicities. Okay, so we're going to go here with a 1. We're going to go with a 1 here, and we're going to go with a star. Even though it's somewhat redundant, it's already implied with the diamond. If the diamond was not there, they would not be implied. Right? We wouldn't know how many are participating. Yes? Right? If the diamond weren't there. But because the diamond is there, it's already implied that it's one-to-many. Right? But even though it's implied, we're going to put them anyway. So it is required in our UML diagrams in this class to always put the multiplicities, even if it's obvious. All right. Okay. Yeah. So there it is. One-to-many. There's a one-to-many. So then once we've done it one-to-many, we then ask you to do it yourself. You say, okay, well, once you've done this, now you try using this example, create another one-to-many relationship between the blog and the post, right? Again, that's trivial, right? You're going to go from, you're going to be creating the one-to-many relationship between the blog and the post. Yes, right? Okay, then a many-to-many relationship. So a many-to-many relationship is when one instance of a class is related to many instances of some other data type, and one of these data types is also related to many of those. Like a student might be enrolled in many sections, right? So from the student's point of view, right, there's only one student, and they're related to many sections. Now, from the section's point of view, it's also just one section, and it has many students related to that one section. Make sense? Right. So we say the jargon is that there's a many-to-many relationship between students and sections. Many students are enrolled in many sections. Yes. So we want to be able to capture that as well. Right. So to capture that, what we're going to be doing is capturing things such as, for instance, the when you create a post, okay, yeah, folks can rate it. Right, can rate your post. Okay, for instance, I might say, oh, that's a great post, right? I can maybe I could give it a thumbs up, thumbs down, or I can maybe select how many stars, right, between a range, right? Or maybe I can leave a comment. So there's many ways that users can interact with whatever you have written. Okay, and those relationships are many-to-many, right? So from the point of view of the user, I'm going to rate many posts, right? I'd say, well, I like that one, I don't like that one, I'm going to leave a comment over here. Yes. So from the user's point of view, I am rating many posts, right? Also from the point of view of the post, there are many users who are going to rate that particular post, right? So it is a many-to-many between these two pieces of data, right? Yeah. So they can they can dislike a post, they can leave us a star rating or a score, right? So many users are going to rate many posts, and many posts are going to be rated by many users, right? So that kind of relationship we refer to as many-to-many. Okay. So let's implement a rating class, okay, that's going to keep track of this information, right? How many likes, or how many, what's the score, or if you left a comment. And also some auditing, when was this created and when was this updated? Make sense? Right? So yeah, so to implement that, now if the rating were, instead of a rating, if it were just likes, right? Just likes, then we would not capture, right? If it was just likes, if you would implement something like this, you'd say like that, right? And then you call this likes. Okay. If it's just likes, then there's no need for an extra class. From UML's point of view. From UML's point of view, this is already a many-to-many, right? And this is how you would implement it. You'd say star and a star. You're done. That's a many-to-many, right? Many users like many posts, right? And the name of the relationship is likes. So from UML's point of view, UML 2.0, the latest version, that's all you need to do. But here we have something slightly different, right? We're not just capturing whether it's likes. We want to be able to describe the implementation, right? We want to say, well, not only do you like it, right? You can also give it a score. You can give it a whole bunch of other things. Yes. So definitely we need a class because we need to capture a whole bunch of other things. Yes. Yes. So, right. Exactly. But even here even here, right? When it's just likes, there's no way that you would be able to implement this in SQL, right? Because where am I going to put that information that so and so likes that post? Where am I going to store that? Am I going to store it in the post? Well, no, the post is only going to have one place to put that information. But if I have 100 people that like this post, am I going to have 100 records? That makes no sense, right? Or am I going to put it on the user side? If I like 200 posts, where am I going to store the information of which post do I like? I can't store it in the user. I don't have arrays. I don't have like an array of things that I can store. Yes. Yeah, this is an association. This is exactly. We don't have to draw the extra. Oh, you mean the association class? Yeah, association class is when you need more than one attribute. Yes, exactly. Yeah, if there's just a likes, you would leave it like that. It's perfectly fine, just like that. Okay. So even though this is perfectly fine if it's just one attribute, just likes, the likes attribute, this cannot be implemented in SQL, right? So we have to reify this, right? We have to convert it into something that can be implemented in SQL, right? It says, well, this eventually needs to become a table, right? And so you would convert this into an equivalent. Okay, so I'm just gonna copy this. I'm just gonna copy these two. And I'm gonna reify this. And so to reify it, we implemented as follows. Now, because these eventually are going to become tables, this would have to have a field where you have some kind of user ID and some kind of post ID, right? That says that, hey, that user likes that post over there, right? And these would be foreign keys, so it would be implemented. It would be implemented as one many-to-many would be converted into two one-to-manys. Okay, well, this is none and none. Okay, like that. So this would be a add multiplicity. So this would be star. This would be 1. And same thing here. This would be star and a 1. Now from yes. Yeah. So posts can have 0 like, but how can a user like a post that doesn't exist? No, you wouldn't be allowed to do that, right? The record would only contain where you have foreign keys to an existing user and an existing post, right? So for instance, what we would do is that we would force the combination of post ID and user ID to be the primary key. Right. So for instance, then that would, would allow a user to like a post, but not like it twice, for instance, right? I can't like the same post twice, right? Because the combination of post and user would be unique, right? And because they're foreign keys, the values that you put in there would have to be not null, and the values would have to be of records that actually exist. Yeah. Yeah. Also, I noticed that instead of camel case, you use underscore. Right. I was about to remove them. And the reason I would remove them is because from UML's point of view, these fields are redundant, right? From UML's point of view, it makes no sense to put them because the lines already imply the foreign keys, right? And in the algorithm that we saw on Tuesday, right, we saw that there's a direct correlation between being on the many side, right, on the star side, and that being a foreign key. Right? We said if it's a foreign key, then the star is on your side. Okay. So yeah, so definitely the user would be pointing to the user. Well, actually not. This would be user. Right. And this would be likes, right? So this is how you would implement the likes. Yes. Right. It means that if that one record only contains foreign keys. That's all it contains, right? And the table says everything you need to know about what it means that there's a record in that table. Yes, it says that this user likes that post. There are no other fields, only the foreign key, the 2 foreign keys. Make sense? But we weren't asked to just implement likes, right? We were asked to implement something a little more than just likes, right? We were asked to implement, yes. Right. So because the UML is agnostic to the way you're going to implement this. If you're going to use it, if you're going to use Java, C#, SQL, it doesn't care. It implements the data structure at a very conceptual level, right? So those 2 fields are specific to the fact that you want to use SQL. But if you're using Java, then those 2 fields makes no sense, right? They would instead maybe be a pointer or be a reference to a variable, right, of some type. They wouldn't even be integers, right? So we would typically leave them out, right? If we were talking about UML, pure UML, right? We would leave them in only if it makes the conversation more clear, right? If you're talking about database folks, then that audience, definitely it would help them to see a primary key there and all the foreign keys, right? So if it helps the conversation, definitely put them in there, right? But then we're going to talk with the Java folks and says, why are you putting these IDs and foreign keys? I don't need those fields in Java. So to that audience, you would remove the primary keys, right, and all the foreign keys, and instead put in arrays, okay? And then say, okay, well, it makes sense to them. So depending on the audience, right, you would have different versions of these UMLs for the different audience, just to help the conversation, right? UML is just a conversation tool, right? So it's a tool for documentation, for discussing data structures, right? Now, from the conceptual, from purely UML, when you don't care about any particular audience, right? You would leave out anything that is not necessary. The lines already tell you that there's a relationship. The way you implement it with arrays or foreign keys or whatever, that's an implementation detail. Make sense? Yes, I took it out. Again, if this were if this were Java, we wouldn't even have these likes, right? We would have maybe an array here. We would have an array of people who liked this post, yes, right? And over here, the user, I would have an array of the posts that I like, right? We would even have this intermediate class, okay? Again, depending on the audience, yes. We know we're going SQL. That's what we meant by reify, right? We say, okay, we need to implement this, and the only way that I can implement this in SQL is if I have a separate table, right? So yeah, it's saying the same thing, but for 2 different audiences. Yes. So for ratings, right? Let's talk about ratings, right? Because they're asking us for rating. So it's a little more involved. Here now, the rating is not just establishing a relationship, right? If I so they're asking us for rating, right? So let's copy that. Okay. So what they're asking us for rating, right? And just drawing a line between these 2 and say rating, well, that's not enough, right? Because if I say rating, oops. Well, that's not enough to say rating because there's a whole bunch of attributes that describe the rating, right? Not only do I like something, maybe there's a score, maybe I left a comment, maybe whatever, right? And so just saying rating is not enough to say, well, a record of that is related to a record of that. I want to describe the relationship, okay? Right? It's not enough to just say, oh, there's a rating. Well, what is a rating? I need a place to store that, yes? Okay. Now in UML, the way you implement that in UML, we said that we would use an association class for that, right? An association class. And association class is as follows, right? We say that this was a dashed line like that, right? And then we would implement another class that would sit below it, which is the actual rating, right? Like that. Oops. Okay, and then we would have a line that falls right there. Okay, that is the correct way of documenting the fact that, yes, there's a rating, but I want to tell you more about that rating. Okay, obviously there's a many that goes across these two. There's a many. So this is multiplicity. So it's a many on this side, many on this side, and many on that side. Okay, and the rating, we say that it's going to have fields such as likes, which is an integer, score, I think is also an integer, comment, which I think it's a string, and also created, which is a date, and updated, which is also a date. Hide, how do I hide this? There we go. Yeah, so that's how you properly document the fact that there's a many, and the many is capturing all these things, right? Like, score, blah, blah, blah. Now, can we implement this in SQL? Not quite, right? We need to reify this. Yes. Oh, is it? Yes, thank you. Okay. So yeah, so just like we said that this is enough in UML, this line here going between user and post, just in UML is plenty. That's it. That's all you need. Just that one line with a star. But we had to reify because our audience is SQL. We need to add something that represents the table that we're going to need to capture these two foreign keys. Same thing we're going to need to do for this. There's no way to implement this, right, in SQL. So to implement it in SQL, it's going to look very, very much like this likes over here. So I'm going to copy that. I'm just going to paste it underneath. Where is it? I'm just going to put it down here. And so there's going to be ratings, rating, and it's going to have the same fields. There we go. So this is a reified version. This is a reified version of this UML class diagram, right? Looks very, very much like this one. It's just a mapping table, right? That has two foreign keys. Well, this one also has those two same exact foreign keys, exactly the same foreign keys, but it has additional columns, right? It has a Boolean for the likes. It has a score it has an integer for the score. It has a string for the comments. Yes. All right. Yes. The reified version. Yeah, always reified. Yes, it has to be reified. Yep. Yes.
The association class is only used in pure UML.
In pure UML, yes. If you're not going to be talking to if you don't know who your audience is, you might as well just stay in UML. And again, as a designer, and depending who your audience is, you might choose to add additional fields in there just to help drive the, like for instance, even it might even help, right? It might even help the discussion that you explicitly add the primary keys, right? You say, yeah, yes, there is a primary key. You say int, and you might even say, hey, this is the primary key. Okay. Right. Yes. On what? Oh yeah, oh yeah, no, if you move something down below, it's just adds another page. Yeah. Yes.
So all the items that like created and updated fields, would it ever make sense to just create like a class called blog item with those fields and then have everything be subclasses of that?
Subclasses? Yeah. So inheritance, definitely in UML would be make total sense. That, for instance, all these have these created and updated. Well, why don't we have this global one and everybody inherits from this, right? It makes total sense. The only issue is that typically this created and updated is because, again, it's going to be implemented in SQL. We want to audit this, and it's not really part of the data model. It's mostly for auditing purposes, maybe for the back office. Folks want to keep track of some statistics, but it's not really part of the data model, right? So probably it wouldn't be useful. It would be useful to when you have real things such as employees and hourly employees, where you have a special case or you have a generic and abstract case, and then you have multiple cases of that, then definitely inheritance. And even then, you have to reify that, right? Because there's no such thing as inheritance in SQL, right? And we'll talk about how we do that later on. How do you implement things that are so common in object-oriented programming, such as inheritance? How do I convert that into SQL, right? Yeah, we'll talk about that. Actually, rating, probably you would not have a primary key, right? You probably have two foreign keys, probably one that points to the user. And since we already know that the yes. No, in the class diagram, it would appear only once. Not like I am doing here, I'm copying multiple times. No, it would appear only once. I'm copying it here because I want to show you, well, this is how you would do it in UML, this is how you would do it in SQL, right? So I'm giving you the iterative way. Yeah. Obviously, if you're documenting something, yes, right, you would probably copy multiple times just for different audiences. Yeah. But there would be just one class, that final class diagram. Yeah, so we say user, since this is a foreign key and you're already kind of breaking that fourth wall and saying, I'm only putting the foreign key just because, right, I know I'm talking to SQL folks, right? You might even break your naming convention, right, and even put the underscore there, kind of making it obvious that this is not a UML variable that you would normally have there, right? And it's only there just to make the conversation more, easier, right? So you would say that this is it's an integer. It's usually maybe even a foreign key. You would say that it's a foreign key, and probably you would say that this is the post, ID, integer, foreign key. And referring to obviously the primary keys that would be listed here on the user. This would be maybe ID, and it's an integer, and you would say this is the primary key for that user. Again, in UML you would not put this, right? Just like you would not have it in Java. Yes. Yeah. Sure. So the naming convention that I'm usually following is that all classes will have a field called ID, regardless of the name of the class or the name of the table. The only reason I put a user in front of this, right, is to know that these are two foreign keys, right? The one is referencing the user and the other one is referencing the post. Yeah. But yeah. So for instance, you could follow a naming convention, right, where you always put the table name in front of it and then underscore ID. Yeah, that's a good naming convention. Yeah. Yeah. So this is the many and many. Okay. I believe the assignment then asks you, once we've gone through this exercise and we've kind of told you how to implement the rating between user and post, yes, it asks you to do it on your own, to implement a reply, I believe, a reply class. It says, using the example of the rating class, create another class called reply to represent the reply a user might make to a post, right? So this is me, right? I'm visiting somebody else's post and I'm now replying to them, right? It's almost like a comment, but where one is being used as for rating purposes, this is just me replying to you, and it could even become a self-reference, right? Where I reply to my reply, so it becomes this kind of hierarchy. right? Where, I reply to my reply, it becomes a branch, and then I can branch off if other people are replying, I reply to them. So this becomes this tree, right? Whose the root is the original post, right? So this is actually a little bit simpler. There's the actual string that you reply plus the created and the updated. Okay. All right. All right. So that's the assignment. There's also a challenge. This is for the graduate folks. Although you're welcome to play around with it, exploring the idea of inheritance. Right. Inheritance is totally fine in UML, right? Where you have a special, where you have a base case that you declare a class that has everything that is common amongst several other classes. Right. So for instance, if you have full-time employees and hourly employees and commission employees, right? They all have first name, last name, social security numbers, blah blah blah, right? Birth dates or the date that they were hired or whatnot. And so instead of copying these three fields again and again and again, right? We can instead create an abstraction or a generalization, right? That captures all those fields that are common, and then all the other ones can inherit all those fields and then add their own specific additional fields, right? So we say that these are special cases of this more general case. Yes. So that's why it's called different ways. This is called a specialization if you look at it that way, or it's a generalization if you look at it the other way, or just inheritance. It's also a common name. Yes. Again, if you want to play with that, I'll give you an example of that, and then we ask you to implement your own little thing about vehicles and automobiles and boats. Enumeration is also very an important thing that you might use in when you're modeling. Is that, for instance, you might instead of having a here, say we want to capture the role of an employee, right? What is the role of this particular employee? We could leave it as a string. Yes, and somebody can just type what is your role, okay? But being a string, it's a little bit too generic, and you could very easily mistype that, right? And say, well, if I could easily mistype it, and then the role is just captured wrong. The data is wrong, right? It's bad data. So to fix that, what we typically do is that we create an enumeration that captures all the valid values that a particular field could take, so that particular field can only possibly have those 4 values. Yes. So enumerations are very useful for that. Most databases support enumerations. They support it. MySQL supports it with a keyword enum, right? So instead of declaring as a as a varchar, you declare as enum, and then you list all the valid values that could go in that field. Okay. Most other databases don't support enum, right? So it's actually a if you go with MySQL and say, "Ooh, I'm going to use enum everywhere," that makes it actually harder if you ever want to move out of MySQL, right? So the more you use a feature that is specific to a specific vendor, right, the harder it is to move away from that vendor. Okay, the harder it is to migrate away, right? So we're going to be focusing on creating a what we call a portable enumeration, right? Meaning an implementation that can be easily migrated to other databases. Okay. For instance, one easy way to do this is to have a table called roles, right? Where the varchar, and create a varchar primary key called, say, roles, right? And you list all the roles in there, and they're primary keys, so they can't repeat, right? And you list all your roles, and then your field in the table, it would be a foreign key that goes out to that table, right? So now the value of that foreign key can only possibly be one of those valid values that are stored in the database. Make sense? Right? Now, this brand new enumeration table is conceptually different from other tables, right? The other tables, they grow and they shrink as you insert and delete, right? They change over time. You might increase somebody's salary, right? You might, they change over time. The state of each record changes. They're added, removed. Somebody gets fired, somebody blah blah blah. Whereas enumeration tables are meant like, like these are the valid values, okay? And they're not changing very often, right? They're not meant to change very often. It's kind of like where you put some data in there and that's it. It just stays forever, right? So they're conceptually different. They're implemented just as regular tables, right? But they're conceptually meant for this. Also, they're very useful for for a user interface where you might have like a drop down, okay? And you click a drop down, and those lists from where you can select, they're typically drawn from a value list table, right? Like a table that contains all the possible values, maybe the label, how it's displayed on the user interface, and things like that, right? Make sense? Yes. Maintaining in? Oh, in code? Oh, you would maintain it everywhere, right? Especially for validation, right? So you would maintain it on the user interface as a drop down, and you would validate that you've chosen the correct thing. That usually that when you submit your selection, it would be validated again with another array of enumerations in the Java code or C# or whatever, would validate it again. And then when it gets to the database, it gets validated again. So typically it goes through multiple layers where you make sure that the data is strongly typed everywhere along the entire stack. Yeah.
Like you just have it as a string and check.
Yeah. So the problem is that somebody might inadvertently actually insert a record in there. Going through if you're an admin or something, you have access to a database, you could insert bad data, yeah, or modify it and change it or run scripts. There's tons of scripts that people run in the back end, and there's many different ways that people use the database other than just the user interface or a particular service layer. Yeah. Or when you're transferring data between or copying or doing all sorts of things that, yeah. So typically it's the validation. I think that the mantra is validate early, validate early, validate often, validate everywhere. I forget. There's a mantra that says, okay, as early as you validate as early as possible, right, and all the way through. I forget what the mantra is. A really good mantra. And then was there? Oh. Okay. Yeah. So the deliverable for this assignment is a PDF document. Right, so you'll do your work on using Lucidchart or whatever you're going to be using. Print it out to PDF and then upload that PDF. Okay. All right. Yes. Yeah. So the difference is that the difference is that this version is perfectly fine. It's perfect, valid UML 2.0, right? But it's not enough for me to go on and convert this into a SQL relational database, right? Whereas this kind of tells me already that this, okay, I'm going to need an extra table in there, and I'm going to need a foreign keys that goes out to both of these, right? So this is a reified or concrete version of this more conceptual version. Yes. Same thing here, right? This. It tells me that it's made in a many, it tells me that it has these fields, but again, this is not quite enough for me. I have to do a little more thinking about it. You would force me to reify it, right? You would put that burden on me having to convert it into something that I can implement. Here it is, right? Where you have the additional table with additional fields and the foreign keys that would go along with it. Yes? Does that make sense? Okay. All right, excellent. Let's go back where we were. I think we did use case analysis. We did UML class diagrams. I believe we had started on data design. Any questions? Anything else? Anything on the chat? Nope. Okay. So yeah, so we had gone through the overarching goal of what we're trying to do, okay, is feel comfortable talking about data, in different contexts, right? We're happy of talking about it in English. We're trying to always convert it into some formal representation, and there's many different ways of representing it formally, right? It could be in some programming language, right, in JavaScript or C# or whatever, right? And with all the idiosyncrasies of that particular language that you choose, yes, with its own specific things. There's the very, very vague and contradictory and inconsistency of English or any language, any human language that you might choose, right? And everything in between, right? And so we're trying to explore what are the challenges of expressing it in different ways, right? We've been spending most of our time since this week of spending our time here, right? But the idea is that yes, we're spending time here, but knowing that we want to get to here, right? Sort of the relational model. And so we've been looking at some of the challenges. Well, okay, well, I could draw something here, but it's not quite implementable over here, right? So I'm trying to understand what the constraints are, right? What the limitations are of our target representation, right? And how we can bridge these two worlds, right? Later on, we'll go a little further and say, okay, well, how can I go from this to here? That's even going to be a bigger challenge, right? A much bigger challenge, and there's tools for that, and we'll spend a lecture talking about how to go from here to here and vice versa. Right? That's going to be really, really interesting. Good question. Yeah. So yeah, we went through a process of design. And I believe we came to the conclusion of converting that we were able to convert. Where was it? We did that, right? Converting tables. Yeah, we did that. Okay, yeah, we did this, right? We were able to determine that we can convert classes to a relational model and vice versa. And we looked at this example, right, of going from a class diagram to a relational model, right? And so we said that the algorithm it's not perfect, right? It does have its limitations, but it's fairly simple. For each class, right? For each class, we're going to create a table, right? For each field, we create an attribute. Well, that's right. That's easy. Then we say, okay, well, if you have if there's choose a primary key, right? Ideally, that primary key would be something natural, meaning something that naturally describes that person or thing, okay? For instance, something natural that describes us could be our name, right? My first name and last name, okay? If you can guarantee that that's unique enough, that's good. Use the first name and last name. But can we guarantee that it's unique? Probably not, right? So instead, we create an artificial key, right? That's what we mostly use. Our phone numbers, our our social security numbers, right? Our student IDs, all those are artificial keys, right? That somebody said, they realized, okay, nobody's unique enough. Nobody's name is unique enough to guarantee that. So we'll just make up an artificial key, and that's where all these numbers, credit cards and blah blah blah, come in, right? Then we went on and said, okay, well, wherever you are on the weak, if there is a weak strong relationship, meaning a one to many, if you have or many to one, then put a foreign key on the weak side. So on the star side, you're going to put a foreign key, and it's relating to the primary key on the strong side, right? So I mean, so that's easy. So that's how we went from the tables and came up with these classes. Okay. Yeah, I'm sorry. Starting from this class, if you apply this algorithm, to this class diagram, you come up with this. These are the tables that come up with this, right? So for the classes are permit, student, department, course, section, and role. And so it comes out to be tables, department, course, section, student, and role, and permit. Yes. And then for each one of these attributes, student name, graduation year, that's what you have in the student name, graduation year. Department, you have department name. So there's department name. Also, we're applying the fact that on the string, if you have a weak to strong relationship, we're going to put a foreign key on the weak side and a primary key on the strong side. And that's where, there it is. That's a primary key for the department. Okay. Although we could argue that maybe you could argue that the department name is unique enough. Maybe that's a good argument, right? The department name within a college, it would make no sense to have two departments that have the same name. Okay, so this would have been totally fine that we would have used the department name as the primary key instead of coming up with a artificial key. Yes, right? But those decisions have to be made case by case. Same thing with the course title. Could you argue maybe that the title of the course is unique enough? Yeah, maybe that's a good argument. Right? It make no sense to have web dev and then web dev again, right? So maybe you could argue that title is also unique enough for it to be the primary key. We'd say that it's a natural key, whereas CID is an artificial key. Yes. Okay. Section. We have the primary key. We have a foreign key, right, relating to the course over here. Enrollment has a foreign key that goes out to the section and it goes out to the student, right? So it's saying that this student is in this section. And notice that it has a primary key as well, right? Well, you could argue that the combination of student along with the combination of the section, that's unique, isn't it? Right? If this is not unique, then a student would be able to enroll in the same section twice, right? Okay, so we could go a little further and say, I don't really need the primary key. My primary key is a combination of these two fields, right? Now, by making this a primary key, that means that the combination of the two has to be unique. Yes? You put, well, this here you would put like curly brackets. You put it like curly brackets, right? In SQL, we'll see later, right? You can declare both of them as a primary in parentheses. Yeah. So you could say, well, I don't really need this artificial key. The combination of this compound foreign key and foreign key is my primary key, and it's unique, right? So that then you would be enforcing a rule where a student could not be enrolled twice in the same section, right? Like this, just like it stands here, it would be totally fine, right? That the same student is enrolled in the same section twice, or 3 or 4. There's no limit. There's no way for this database to limit anybody enrolled more than once, right? What else? Also, here we have the primary key of the permit, right? And we have the foreign key of the student. Yes, right. But we did say, I believe in the class diagram, there's an optional. See that one student can be enrolled, can have at most one permit, right? If they're going to park here in the university, they need a permit to park. Yes, but it's optional. Maybe I don't have a car, so I don't need a permit. Yes, that's why the 01, okay? And so this is either a one-to-one, whether the record exists if I have a permit, or I don't have a record on this side and I just don't have that permit. Okay, so the way to capture that perhaps could be that instead of having a permit ID as a primary key, I could have my foreign key also be the primary key. Okay, so now what I'm saying is that is that this foreign key is either referencing the student and the student has a permit, or if there is no record with a student referencing the student ID referencing the student, then there is no permit. There's a one-to-one, only once. Instead, the way it stands like this, the student can have two permits. You can have two records, the same student ID, different primary key, but 2, 3, 4, 5, 6, 7 different records for the same student. You see that? Right? Because this is not unique, right? This ID is unique, but this is not unique. So I could insert many records for the same student. You see that? Right? So to enforce that it's only one, you only get one, right? I can remove my primary key here and make this not only the foreign key referencing the student, but also the primary key, so it cannot repeat. See that? So I would be enforcing only one record for that one student. Make sense? Right. So playing around with foreign keys and primary keys, right? You can really implement certain really nice business rules, right? And enforcing that the data that I'm capturing is good, right? That I don't have bogus things such as, wait, why do I have 3 permits for the same student? That makes no sense, right? Especially that, because the UML clearly said that you only get one permit, right? So you have to look on ways that the SQL that you get generated, even with this, the algorithm that we implemented, was not perfect, right? It made a lot of, our algorithm made a lot of decisions. Well, not decisions, right? It's very limited, but not implementing, enforcing certain things, right? So we do have to go in and tweak it. So let's see some tweaks that we might make. Yeah. So for instance, we might say, wait a minute, the department name is unique enough. Huh? It's unique enough. I don't really need this artificial key. The department name can be the primary key, and that's it, right? And once I have that, once I have the department name be the primary key, I can go and modify everybody else, right? Who's referencing the department. Yes, like for instance, the student. The student has a foreign key, right? That was major ID, right? It was that primary key that we had there. Well, since I'm not using the primary key anymore, I'm using the department name as the primary key. I can now say major name, right? The chemistry or whatever, the name of the department, right? As opposed to the artificial key. Same thing here, as I mentioned earlier, right? I can enforce the fact that the permit is only one permit per student by making the foreign key to the student, also making it the primary key. Okay. And the enrollment, same thing, right? We have the primary key here, or I can enforce that one student can be enrolled in one section and it's unique. Notice the curly brackets here, curly brackets. I'm saying that this together, these two values constitutes my primary key and it's unique, right? Only one of these. Yep. The combination is unique. Let's see what else. Course, right? Yeah, we could argue that the course ID is really not needed if you can guarantee that the title for the course is unique, right? And that could be your primary key. Ideally, we would use natural keys instead of artificial keys, right? Ideally, but sometimes it doesn't work out, right? So the section, because now I'm using the course title, I'm going to change this from a course ID. I'm going to use the title of the course for the foreign key. Yeah, so the algorithm has limitations. We saw that we did have to go back and fix a couple of things, right? That was not taking into account, for instance, only deals with weak, strong relationships. It doesn't do strong, strong or weak, weak. It doesn't do any of those. But we'll talk about this a little later. A requirement analysis, basically this is just a recap on that the best way of designing a good database, a good relational database, is to first design a good UML diagram. Okay, first start at the class diagram. If you have a good class diagram, you'll typically have a good relational database. Interviews, we talked about this last time, right? For instance, you have a university, like the university problem. How did we come up with with these tables and classes? So let's see. If somebody we might interview the dean, and we might interview a whole bunch of academic folks in the university, and somebody might ramble on describing how universities work. We talk about, and somebody came up with, the university is composed of departments, and academic departments such as mathematics, drama departments are responsible for offering courses. So us as engineers, we're very keen on looking for nouns. What are the nouns, right? And as these folks are talking, and we're transcribing and making notes, we're looking for all these nouns: university, okay, departments, courses, and sections, right? Dining halls, and we're looking for all these, and we're also looking for the verbs, right? So after several days of interviewing a whole bunch of people, right, getting a lot of input from a lot of folks, we're going to have a vocabulary. As engineers, we go back to our design tables. It was okay. Well, these are all the nouns that we came up with, right? There's universities, academic departments, courses, and students, and years, and grades, and sections, and professors, and cars. Okay, right? And we also came up with all the verbs and verb phrases, right? There's university composed of departments. Academic department offers courses. Course has sections. Student graduates in a year. Student majors in a department. And student enrolls in a section, right? So the verb phrases create the relationships between the nouns. It tells us which nouns are related to which other nouns. Okay, it's the lines, right? The nouns are the boxes, and the verbs are the lines between those boxes. Yes. So this is kind of giving us a hint of what our initial class diagram might look like. Yes. So having gone through this exercise, we come up with maybe a beginning of what a class diagram might look like, right? Where we have all the nouns and students and permits and years and car models, sections, courses, professors, departments, grades, and then all the verbs that connect them. Okay. And this becomes kind of like our very first class diagram, which is very, it might be very naive, right? We might have a lot of errors or a lot of mistakes, and we're going to iteratively, right, criticize this and talk it over with our other engineers and see what's wrong with it, right? And over time, right, we want to distill it into something that is the more akin and represents the reality. Okay, right. So let's do that exercise. So we have student receives grade, student majors in a department offers courses, right? A section has course, section has, a professor teaches a section, right? The student receives a grade, the professor assigns a grade. So it looks like it's capturing a lot of what we want, right? The student is issued a permit. The permit is for a particular car that has a car model, a particular license plate, right? So it looks like it's capturing a lot of what we want. What's wrong with this stuff? So analyzing relationships. So let's look at some of the relationships. First of all, we need to start removing certain things, right? Obviously, the more you know about a particular domain, the more you can draw these lines. Yes. The less you know about a particular domain, the less you know about how do I draw this, right? If you know your physics and you know that an atom has multiple electrons, right, and they're both nouns, right, and that there's a one-to-many relationship between one atom having multiple electrons, maybe you would know to draw a one-to-many between atom and electrons. Yes. So the more you know about a particular domain, the more you can draw these lines and know about the relationships. Yes. But the vice versa is true, right? The more you know about a particular domain, the more you are confident on what you're drawing. Yes. So analyze it. So we're trying to find out if some of these relationships are irrelevant, right? Whether they're redundant, okay? Whether most of the relationship that we typically draw are mostly binary between two nouns, but maybe there are three nouns that are related and not two. Maybe there were four nouns that were related and not three, right? So we're looking for those kinds of things, okay? So for instance, we have from the student record, we see that we can follow three relationships, right? Majors in to get to the corresponding department. So between the department and the student, there's a majors in relationship. There's also enrolls in that relates to student and the section. Yes, that's another verb phrase. Enrolls in and has to get to course, right? So if you follow these two relationships, you get to the course, right? That the student is enrolled in. Okay. Now depends how we read the text, right? Depending on how we read the text, we might draw the wrong thing. Okay. For instance, instead, what we drew here. What we drew here between sections, courses, and students, we drew it student enrolls in section and course has section. Yes, that's what we drew. But we could have done this instead. We could have drawn this, naively. We could have said student enrolls in course and the course has sections. You see that? We could have drawn this. It makes total sense. Where do you enroll in? I'm enrolled in the course web dev. Yeah. And it says, and does it have many sections? Yeah, it has many sections. So we could have totally said, yes, I am enrolled in web dev or databases or whatever, right? And yes, it has many courses. So depending how you read the phrase, you could totally done this, right? Now the problem with this particular drawing, right, is that there's no way, there's no query that you can make here that would tell you what section is this student enrolled in. If you create the tables and you do all the records, right, and you insert a whole bunch of records, right, there's no query that will allow you to answer the question, what section are you enrolled in, right? Because of all the foreign keys go out to the course. See that? It goes out to the course, and there's no way from here to know which student is in what particular section. You can only answer that the other way around. If you start from the section, right, you can see, okay, well, these are all the sections that are for that course. And for that course, you can say what students are in that course, but there's no way for me to answer what section are you in. Hence, I don't know which room should you go to. Hence, I don't know who's teaching that particular section. See that? Right. So even though the drawing looks innocuous, it's inadequate, right? There's no way that I could capture the information that I want. And so deciding that actually the sections should be flipped, okay, that the relationship that we want is really the student with the section and then with the section with the course, is the process of designing the database, right? And that kind of question has to be done for every single relationship that you have to look at it. It says, okay, well, if I insert this, can I then can I answer the questions that I need, right? Right, and that's stipulated in the requirements. If it's not in the requirements, you can easily run into these issues. Yeah, so you have to exhaustively consider every single path in your class diagram and ask the question, is what I'm storing here, right, what I want? Can I answer the question that I need to answer, right? So here's another one, right? Here you have a student receives grade and the professor assigns the grade, right? So there's no capturing of, yes, you got a grade, but wait a minute, on what? Right? Because you could be enrolled in a whole bunch of sections, yes, and you got a grade of A, and you got a grade on A on what? On web dev or databases, or what did you get the grade on? But there's no relationship here that says, oh, you got a grade on the section. So we're missing here a line that in between that says that it's not a binary relationship between professors and students, but also there's a tertiary relationship between the section as well. Yes. Yep, exactly. Yeah, so right, exactly. So then you create cycles. For every cycle that you find, there's a potential redundancy, right? You especially cycles, you want to make sure that you're looking carefully. Yes.
Why do you need a connection between sections? Because doesn't the professor tell you already?
Well, the professor could be teaching other sections, right? So just so you know that I gave you the grade, I could be teaching other courses, right? So you don't really know on what really, right? Yeah, so we might need more things like that. It captures grades professor gave, but not the student in the section, right? So we're looking for all these inadequate relationships. Okay, and usually these inadequate relationships is because we might have oversimplified it when we were reading the phrase, right? And we realized that we were creating the relation. We were so focused on the relationship between two nouns and the verb between those two nouns. Okay, and we didn't realize that the phrase is actually a little more complicated, right? And so instead of reading, student receives grades, if we would have read this a little further, we might have realized that no, wait a minute, student receives grades for an enrolled section, right? So it's this whole phrase that is relating three things, not two. Right, same thing here. Professor assigns a grade. Same thing. Your professors assigns grades to students in their section, right? So we need to reinterpret the English, go back and then fix the diagram, right? Yeah. So it's a multi-way relationship. It's more than two nouns. So let's take a look at this one. Student receives a grade, just a many to many, right? Now, so if it's relating two nouns, well, that's easy. We can just reify that and put a table in between. But we could apply the same principle with any number of associations, right? Not just binary. Even if it's tertiary, right, where you might have three things that are associated, right, with this conceptual dot in between, saying that there's a relationship between these three. Okay. Again, we can apply the same principle of reifying and convert this conceptual relationship, right, and replace it with an equivalent table with foreign keys, right, where now you have a foreign key to the grade, a foreign key to the section, and a foreign key to the student, saying that this student in that section got that grade, right? So the reify technique, it's very, very useful, right, to convert things that were verbs, right? Things that were verbs, convert them into a noun equivalent, right? Now it's a record, right? The grade assignment. Now it's a verb. Now it's a noun, which used to be a verb, right? Yeah. So now there, as we'll see a little later, this does have limitations. Okay, it has limitations, and oftentimes it converts or it converts fixes one problem but introduces another introduces other problems that you need to deal with, right? And we'll see what the limitations are of this principle, right? That you have this three-way, four-way relationship, and you just slap on a table there. Yes, it works most of the times, right? But you have to be careful. It has its limitations. Reified, right? So yeah, so the way the way we can go about it is to replace this verb with an equivalent noun that has foreign keys to the original records. Okay, so here more or less the same. The steps to convert into something concrete. You have the relationship. It's a class. It's like a verb. We're going to convert it into a noun, right? So receives becomes reception or receiving. Reify is easier than a three-way relationship. So you're converting something that is binary relationship, and you can deal with more bigger relationships that, greater than just binary. So yeah, so applying that principle, basically what we've done is that we're going to replace this student, grades, and professor. We're going to convert it into grade assignment, right? That references the student, the section, the assignment, and the has grade. Yes? Okay. We still have to deal with an issue somebody pointed out, right? What about this triangle over here, right? We have this teaches in here, right? That seems kind of redundant, right? Because we're already capturing the fact that this professor gave that student that grade in that section, right? And if we know that there's only one professor per section, then why do we even need this, right? If we already know there's one professor per section, we know that this professor is in this section, we don't really need this, Okay, so what this line is here is now it's redundant. It's a redundant information here, right? The way you implement is with a foreign key. Right? The section has a foreign key pointing to the professor, but there's already a foreign key pointing to that professor from here. Right, so we're capturing the information twice, right? And you know what we said about redundancy? Redundancy breeds inconsistency. You know, what if we inadvertently have a reference to this professor for that section, but then we have a different professor teaching it from here, right? That would be that would be inconsistency, right? If I ask from the section who's teaching that section, gives me Professor A, but if I ask it this way, it gives me Professor B. That makes no sense, right? So we want to eliminate any redundancies, right? And in this case, we're going to remove this teaches from here. It's redundant. Okay. Yeah. So redundant. So there's several redundancies. Yeah. One. Yeah. This one, right? The assigns. Well, we could go either way, right? We can remove the assigns here, or we can remove the teaches. Either one, right? Actually, at the end, what we're going to do is that we're going to decide that professors are not important enough to have their own table, right? And we're going to actually convert the class. We're going to convert it into an attribute of the section. Okay, that's another step in the design process, is asking yourself, is every noun a class? Maybe not, right? Maybe some nouns can just be part of bigger nouns, right? Could be attributes in bigger classes. Yes, so that's one of the steps in the design phase. All right, let's leave it here. And yeah, so please wrap up DB1, and you can get started on DB2. And remember, there's a quiz next Friday. All right, excellent. Thank you. Have a great weekend. Bye-bye. Have a great weekend. Bye. Great.